Dr. Ashwinikumar Gupta. Today we'll be doing on a very important topic, name reaction. What are name reactions? Name reaction basically are those reactions which has been carried forward by some particular scientist who has studied on the conversion of one functional group to other in presence of some particular reagent or some conditions. So those reactions are given the name of that particular scientist as a sense of respect, no doubt. Now, why do we do name reactions? Name reactions are such an important key concept in chemistry which has been required either by class 11 students, class 12 students giving their entrance exams like JEE, NEET, IIT, MHT-CET, and those students who are pursuing their BSc, MSc, and also PhDs. So today we'll be studying about a very important name reaction, which is a oxidation reaction. Generally we see that oxidation reactions are done in presence of some K2Cr2 or KMnO4, which regularly up till now we have seen CrO3, pyridinium chlorochromate, but this oxidation reaction is done in some different reagent, and which is very important. And by in this name reaction we will see the most important, the mechanism, which is a point of concern for everybody, how the reaction has taken place. So this Baeyer-Villiger's reaction basically is a 4-step mechanism, and just now we will study the in detail now. Baeyer-Villiger's oxidation reaction. It's a classic organic chemistry reaction where aldehydes and ketones can be straight chain ketones or even cyclic ketones, where aldehydes are oxidized to carboxylic acids as usual, and if it is ketones, straight chain or cyclic, gives us esters or cyclic esters like lactones, right? Once again I'll confirm it. Aldehydes and ketones can be straight chain or cyclic ketone. So aldehydes are converted into carboxylic acids, straight chain ketones are converted into straight chain esters, and cyclic ketones are converted into lactones, which are nothing else but cyclic esters, in the presence of very specific reagents like peroxyacetic acid, which is a OO peroxide linkage, and a very important reagent metachloroperbenzoic acid, which generally we refer as MCPBA. Yeah, we will go through the mechanism first. Mechanism is very simple. It's a 4-step mechanism. Don't get carried away कि भाई 4-step है, बाप रे बहुत difficult. No, it's a very simple. It's a basic name. The carbonyl oxygen has a lone pair of electron. It gets protonated by peroxyacetic acid. ठीक है? It gets protonated ketone and forming a percarboxylate. Now second step, the percarboxylate O minus attacks on the electrophilic site of carbon, on the electrophilic site, thus resulting in a breaking of the bond, and the oxygen atom accepts the lone pair of electron, right? Pair of electron, and there is a bond formation between oxygen, C double bond O R, which is an intermediate. Now the third step happens to be a type of rearrangement reaction. A rearrangement reaction, we can see a lone pair of electron, it forms a bond, and due to which there is a shifting of this particular R2 from here, and thus this is a very good leaving group, and this parts off to form a carboxylate ion, and here there is a rearrangement. Now this particular reaction is more the rate of the reaction is more dependent on the particular R2, the second, which I'll show you in the henceforth topics. Now the carboxylate ion, the anionic O minus will accept the proton, and due to which there will be the positive charge is neutralized, and we get a particular ester, and this becomes an acid, carboxylic acid. Okay. Once again I will go through the mechanism. See, O gets protonated to form a protonated ketone, and a percarboxylate. This happens to be in fact a very good leaving group. Now the percarboxylate O minus attacks on the electrophilic carbon atom, thus forming a single bond, and there is a formation of a peroxide linkage. Now the third is a very important rearrangement reaction. The most important role is played by the second alkyl group, which gets shifted. Thus there is a breaking of this particular leaving group, OCOR, right, forming a carboxylate. And this, now the carboxylate O minus attacks on this proton and we get a neutral O, okay? And we then, this results in formation of an ester and a carboxylic acid. Now this, suppose now this is a unsymmetrical ketone. In unsymmetrical ketone, what happens? The R2, as I told you, the rearrangement reaction, where there is a shifting, as we see here, there is a shifting of the R2, that is the alkyl group. If the migration attitude of the particular alkyl group is good, then the rate of reaction is very fast. So it is generally, now we have, suppose we have a tertiary alkyl group. Tertiary alkyl groups are electron rich, right? It will stabilize the electrophilic site. It will stabilize the positive charge which is on the carbon atom, thus resulting in a transition state. Yeah. Now it can easily shift. There is a easy rearrangement reaction. Now the general order of this migrate tertiary alkyl group is preferred over cyclic hexyl, then secondary alkyl, benzyl, phenyl, primary and methyl. That means methyl is given the least preference, and tertiary alkyl group, obviously, no doubt, since 3 alkyl groups are there, there is more electron donating, right? And phenyl, because phenyl obviously is more, because it provides stability towards it. Then primary and methyl. Now, this is an example. If I take a cyclic ketone like cyclohexanone, same peroxyacid acid, right? This happened here. Thus we form, this is the acid which is formed as a byproduct, and now this is the cyclic ketone or the ester, that is lactone, right? I hope you would have understood this. This is a very simple reaction. Just go through the mechanism. So this is the it was an interesting Baeyer-Villiger's oxidation reaction. There are many more oxidation reactions, no doubt about it, but Baeyer-Villiger is in such a type of oxidation reaction which has been frequently used, and you can take for example for a question point of view for any entrance exam, this R2, they change this position, they change the different alkyl groups here, and accordingly they will ask you about the rate of the reaction. What will be the rate of reaction, what accordingly, right? So there are many ways of the explanation of this particular reaction. I hope you might have understood the mechanism of this particular. If you have any doubt, you can please write it in the comments. Now I'll come with some more name reactions frequently. If you have any doubt, just let me know. In my next lecture, I'll explain one more name reaction, due to which your concept about another very important name reaction will be clear. I hope everything is fine. Just please share this particular video with your friends